Okay, so we're now on to question 7. It says part A, a car of mass m is at rest. A constant net force acts on the car and moves at a distance x in the direction of the force. The final velocity of the car is v. Write down the equation 1 for the work done by the force. Well, that's really straightforward. You should know that the work done equals the force times the distance. It then says write an equation down for 2 relating force F and acceleration A. That's just plain old Newton's second law, F equals ma. That's an easy mark to get there. Next part, it says hence show that the kinetic energy of the car is given by the equation E k equals half mv squared. So we've got to somehow use these two equations to get to this final equation here. So how would we do that? Okay, well the first thing that you should do is say, or this is the first thing I'm going to say, is that the kinetic energy is going to be equal to the work done by this force. Why can I say that? Well, because the work done by this force, so there's a certain force applied across a certain distance, there's work done, that's a measure of energy, that's going to go into the kinetic energy of the car. So the total kinetic energy gained by the car is going to be equal to the work done by the total work done by this force over this distance. So I can set this equation up. Okay, I'm then going to just swap the F for ma, because if F equals ma, I can, instead of writing F, I can write ma and then the x. Okay, so let's just rewrite this over here. So the kinetic energy is equal to ma x. Okay, now I need another equation, and I need another equation that's going to help me get to this final answer. Okay, so I'm going to need an equation of motion. Which one do I need? Well, you're going to need this one. So v squared equals 2ax. How do you know to pick that equation? Well, we know that we need a v squared in our final answer. And if you need another equation, that equation that you need to pick must have similar or must have terms that are the same as the one you've got, because then you can substitute one equation into the other. And it does have. This term has ax, and this term also has ax. Okay, so what I'm going to do now is exactly that. So I'm going to substitute one in for the other. So if I solve this for ax up here, I get ax equals the kinetic energy over the mass. I can then go and substitute that into here. So v squared equals 2, and instead of ax, I'm now going to write the kinetic energy over the mass. And then hopefully you can see now that all I've got to do is solve for the kinetic energy, so I get that kinetic energy is going to be equal to half mv squared. Okay, m goes up the top, 2 goes underneath, so if you solve this for kinetic energy, you get half mv squared, okay, which is what it asks for. So the key here, okay, is what I did is I originally said that the work done by this force is going to be equal to the kinetic energy gained by the car. So I'll set these two equations equal. I changed the F for ma because it does say to use these equations. Then I need to select another equation to help me get to this final answer over here. Well, I'm going to need an equation of motion, which has got this v squared term in it. Also, it must have similar, or must have the same term. It must have terms that are the same in both equations, so I can substitute one in for the other, which is what I did. Okay, so hopefully that makes sense. Moving on to the next question. It says the braking distance of an empty van, okay, travelling at a steady speed along a level road is 50 meters. The van is now fully loaded with goods and travels at the same speed on the same road. Explain whether or not the braking distance would be the same. Assume the driver applies the same braking force. Okay, so we've got to decide, will this braking distance, will it be a bigger braking distance? Okay, well the first thing to do is I can set up this equation a bit like I did last time. I can say that the kinetic energy is equal to the work done. Okay, this F times x, this work done, is the work done by the force. The total work done by the force must be equal to the total kinetic energy. Why is that? Well, the total kinetic energy will have some value, okay, because it's going along a steady speed on the road. That kinetic energy will be brought to 0 because obviously it's a braking force, it's going to bring the car to zero. Okay, so therefore that kinetic energy that's going to be lost, bringing it to zero, must be equal to the work done by the braking force. Okay, now we need to figure out, because this is the work done by the braking force, we simply need to figure out, does this x distance change? Okay, well, it said that f is held constant. So if f is held constant, the only way x can change is if the kinetic energy changes. So all we've got to ask ourselves is, does the kinetic energy change? Well, that depends on half mv squared. So let's just have a look. Does it change? Half is a constant. That's never going to change. Does m change? Yes, because it says the van is now fully loaded. So m is going to go up. Does v change? No, because it says it's the same speed. So if v stays the same and m goes up, the kinetic energy will go up. Kinetic energy will increase. Okay, if the total kinetic energy goes up and f stays the same, x must increase, otherwise this equation will be complete nonsense. So if f is held constant and the kinetic energy goes up, then yes, definitely the braking distance will not be the same, it will be larger. So how do we write this down? Okay, well, I would write down, the first thing I'll write down is that the kinetic energy will increase, okay, because m increases. So the kinetic energy will increase because m increases. Okay. Then I need to go on and say, I would say that, let me have a look. So since kinetic energy is proportional to x, and the braking force is the same, okay, x must increase. Okay, so I might just write a simple conclusion, that the braking distance, sorry, I misspoke, braking distance will be greater than 50 meters. Okay, so just to go back through that, so we know that the work done by the braking force across this distance x is going to be equal to the kinetic energy that's lost by the car. So I can set these two equations up. Okay, if f is held constant, the only way x can change is if the kinetic energy changes. The kinetic energy does change because the mass increases, because it's now a fully loaded van. If the kinetic energy increases, then the braking braking distance must go down. Okay, because if the force is the same and you increase the kinetic energy, the braking distance must go up. Okay, hopefully all that made sense. And then I'll go on for the final question, part 8, in the next video.